Greetings. In this video, I will discuss my experience debugging a slow page load that was due to a doctrine association. I just needed an API endpoint that returned some history for a financial asset. The history was kept in materialized views, monthly history, and to date history, foreign keyed to fund code in the funds table. There are not many records. For monthly history, there are 12 months in a year for the past 10 years, so maybe 120 records. There is like 10 or so financial assets. So not a whole lot of reasons for it to be slow, and in fact, I actually thought that my computer was just getting old. But eventually I got tired of waiting on the pages to load, so I decided to throw my profiler in and see if anything interesting going on. The first step in these kinds of problems where you don't even know where to begin looking for performance issue is enable profiler in your xdebug. Here I have xdebug profile enable 1, and I have output set to a directory where I can find these dumps and the name of the file so I can actually catch these dumps and they don't overwrite each other. Then restart your built-in PHP CLI server, refresh the page, and wait for a few minutes for these profile dumps to be generated. They really slow the page down. Now look at the latest date or whatever date makes more sense for that page load. The one that was giving me problems was 1291. So that's the one that I will go to Tools, xdebug profile, Analyze. And once this loads, this will show me what exactly happened during the page load. Let's look at what function took the longest. We have gather raw data that took 37% of the time, and it took 20 of whatever unit this is. Not that important, but look here, 20,000 calls. Why is gather raw data being called 20,000 rows? And then hydrate row also 20,000, contains key 40,000, so really crazy numbers in a number of calls. Let's see what that looks like in a call tree. We expand this, expand the largest numbers. That's our expressive application running. Expressive sure has a huge call stack. And just now I finally managed to get to the part where my code gets executed. And we see that the problem begins in Doctrine Entity Finder. Okay, let's resume at this point. What is it trying to find so hard? Expressive call stack is so large that it doesn't even fit in a window. Okay, so here we have our confirmed suspicion that there is no one function that takes a lot to run itself, but there are so many calls that each individual call adds up to a crazy number we don't want. Let's go to one of them and see what it is working so hard to do. Jump into source. We have this gather raw data. And we have this for each loop. Okay, that could be a problem. Then we have another for each loop here. So keep that in mind. We have something that is sitting inside of a for each loop, and it seems to want to iterate a whole lot of times. So let's also check if this is inside of any loop. This one isn't. This one is in a next. Okay, so it's not exactly a loop, but it's inside of an iterator. Okay, so that could be something to keep in mind. We're inside of an iteration. There is a loop here and there is a loop here. Let's see what data we are getting at this point. So we have data. Okay, that looks about right to me. That looks okay. But as I'm cycling through these data sets, I'm noticing that these numbers are looking very familiar. I'm fairly sure I have seen 2014 2.47 already. Let's go some more. There we go. Yes, we are in fact seeing the same values over and over again. This feels a lot like a cross join, which is strange because all I'm doing is doing a funds money to one with monthly history and yearly history. Okay, that's enough of you. Let's see what query doctrine actually generates. I know that this is happening at the risk calculation middleware. Right around here, this is where I'm getting the query fund code. To see what query doctrine generates, we have to first create a debugging stack object. This thing will just keep track of all the things that the doctrine is doing, and then we have to attach it to doctrine's database connection. That typically comes from the entity manager. Get connection, get configuration, set SQL logger, the login stack. Then we let doctrine do whatever it is that we want it to do. And at this point, we can look at what happened in the stack. This is a middleware, not a handler, so technically I shouldn't have any output from here, but I think I can force it for now with new JSON response and pass it this stack, which it should encode into a nicer view. And we have our doctrine log. We have the query that is being executed and the parameters given to it. Let's see what this is doing. Opening a database console. Do some formatting. Okay, a bit more readable. So we have a select of funds table, that's this one. Left join on the yearly history and another join on the monthly history. Let's quickly finish filling in the fund code. And if we run this, we get a quite exuberant amount of records. We absolutely do not want 1,704 records. That doesn't make any sense when we're only supposed to have maybe 120 records at most. Is there anything wrong with these left joins? Let's see if we take one of them out. And now we have only 12 rows, which is significantly more acceptable. So the reason that this is giving all these extra records in a cross join style, even though it says left join, is because I know that this particular data does not have anything common between yearly history and monthly history. And the way SQL works is if there is nothing common between those tables, it's going to do a cross join. That is, for every single record in one of the tables, it's going to do all the records in the other table. Now, where could these left joins come from? In Doctrine, they're typically generated by eager associations between entities. What I had to do was create an entity for value objects, unfortunately, because Doctrine has a limitation that at the moment does not allow value objects to be in separate tables, but only serialized fields in a single row on one table. In my case, I have a portfolio entity that has several array of past performance value objects, and those live in their own tables, and they are non-unique collection of floats and date ranges, unlike unique funds, which are entities, proper entities. So what does my relation look like? In a portfolio XML mapping, we sure enough have our eager fetch mode, as opposed to lazy, that it should be. Why did I have eager there? Probably back when I only had monthly history, I did some premature optimization where I said, well, I'm confident enough that whenever I query for funds, I will automatically want monthly history, no point for this extra database strip, and so I made it eager. Premature optimization because, well, there isn't that much extra work to go to a database versus having a huge query result from the database that you have to then sift through and delete all the duplicate columns and rows. But then once I added other types of histories, to date and the yearly histories, I inadvertently linked to tables that do not have anything in common with each other. And so what probably used to work in the beginning as an eager join became a gross join once I added these other two relations. Let's see how much better my profiling was at that point. I know I have another profile that was after the fixed time, 3563. Let's see the largest number of calls to a function, and much better, not any 20,000 crazy number, only like 1,000 something.